Hi, I'm Adam. Happy New Year. Welcome back to Godot Game Lab. This video will be quite a bit different from the usual ones. Some of you have requested for me to do an unedited style video where I go about planning the architecture for a game like our Slay the Spire clone. And I figured we could do this for the Season 2 thing, right? Because I have to come up with the architecture eventually. So why not record the process and maybe we can learn something along the way. So this video is virtually unedited. You can hear all my ramblings and ideas, but I make sure to edit out long silences where I neither say anything interesting or anything at all, neither draw anything in my board. So this is essentially just a quick cut of the silences because I value your time and I don't want you to sit here and just watch empty frames basically. But other than that, it will be unedited, so prepare for a lot of mistakes, non-coherent, rambly sentences and stuff like this. But anyways, why don't we just go ahead and start this? So the first key thing to think about is essentially our code base, right? So what I mean by code base is key features or pillars, what we want for our code to be like with the end product, right? So what we want here is, these are just reiterations of some points I already mentioned in the Season 1 video. We want the code to be modular. And this means basically that it consists of short scripts, right? And we did this in Season 1 because if you remember, the longest script is like 110 lines of code with white spaces, and that's absolutely fine, I think. Besides being modular, we want it to be flexible, right? And what do we mean by flexible code? We mean that there's not much dependencies between the different systems. So we can test them separately, we can use them separately. And in system terms, we usually call this loosely coupled. So the systems are loosely coupled. Coupled. Which means that they don't have hard dependencies between each other. We also want this code base to be scalable. And what we mean by scalable is that we can add new content, and we expect it to still work if we want to provide new features. And also kind of connected to that, but it's worth mentioning on its own, is that we want it to be easy to add new content, right? Because Slay the Spire is a really content-heavy game, which means that oftentimes we want to introduce new cards, new enemies, new relics, or new stuff, and we want this to be as easy as possible. Why do we need to iterate or reiterate these points when we think about architecture? I think it's important to keep these in mind while planning what we do next. Because we can come up with ideas which would violate either of those. And when that happens, we have to think about, okay, is there maybe another solution which doesn't violate this, these pillars we have here? And if so, it might worth reconsidering going with the other solution, right? Another key thing here is that, and that's actually really important when you plan ahead your games, is that this time we don't start from a blank canvas, right? Not a blank project. Why is this important? Well, when I first did this tutorial series, Season 1 of the Slay the Spire course, I had no plan or intention to go ahead and do a Season 2, right? But most of you like my channel or visit my channel or know my channel because this Slay the Spire content, and it seems like you're really interested in how we can build upon this or how we can continue. And that might be a problem because I wasn't planning on doing a Season 2. So the systems we have in place were not planned with the Season 2 in mind. And what this means in architecture terms. I think that leads to two things, basically. One is that we might need to refactor things. And refactoring means it's a computer science term, which means that we have to redo the same functionality, which essentially does the same thing. So it sounds counterintuitive, because why would we do something that we already have again? Well, to make sure that it fits the big picture, right? So if we had a system which wasn't modular or flexible enough to add the new stuff, we need to revisit that and rewrite it so we can add the new features. So we have to keep in mind that, yes, we have our code ready in season 1, but we might need to refactor some stuff in order to implement all the new features we want. And another thing is we need to make sure that we understand what we already have, right? Because if we want to build on that, we need to understand what we already have. So we need to have a good understanding. An understanding of existing technologies, or the existing code, we can say, for shorter. So these are some starting points we have for the architecture. So what's next? I think it's useful to think about the features we want to have for season 2 next. And this can be like a list of features or something like that. And why do we need the features? First of all, it gives us sort of a to-do list, basically. What do we need to do? What do we need to implement? And also, for the features, we want to order them in the order of implementation. Why does this matter, right? Two things, I think. Because one feature might depend on another one, right? One feature might depend on another one existing. Depend on another one. And that's really important, right? Because if I think about, let's say, we'll have relics, and oftentimes relics inflict status effects on enemies or on the player or both. So it might make sense to do status effects first and then implement relics, right? Because the relic system might depend on the status effect system existing, right? So we need to provide an order which is logical in terms of having the dependencies ready to go when we implement a new feature. And sort of connected to that point, we want to make each feature testable on its own, right? So when it's a really, really bad scenario when we implement a new feature, but we can't test it. And it's again a dependency thing, right? Because if you want to create relics which apply poison or something like that, vulnerable or weakened, like these effects in Slay the Spire, we wouldn't be able to test them because there's no status effect system is in place. And that's a huge problem because you can't decide if your feature is working or not if you can't test it, right? So we need to create an order. And I think we can do that next. So why don't we create a list of features we want for season 2? Let me pull up my cheat sheet for this because I already have some features in mind. And just a quick point here, we could do this tutorial forever, right? But eventually I want to move on to something else. So if there's a feature, well, if I could spell it right. So where were we? Adding features, right? So let me see if I can spell it this time. Features. So I was saying that, yeah, we could add features forever. Like we could essentially do a full clone of Slay the Spire in like 10 seasons or something. But I don't think that's good for either the channel, my own sanity, or for teaching you at all. I want to give you some tools and ideas to do something, but then you can add your own stuff and your own cool features to your own game. But I think we can learn a lot from a season 2 like this. But if you have some feature which you're missing from here, which you would love to see, please tell me in the comments. But I have no guarantee that I'll keep expanding this project because I want to explore other possibilities, other tutorials and courses too. But anyways, what features do we have here? So we'll have, we were talking about relics. So why don't we have relics? Definitely want to do relics. Want to do shops. What else? Statuses, yeah, we were talking about this too. So status effects. Yes, then we want to do map generation, definitely. That's something that was requested a lot. So map generation, we want to have battle rewards, right? So we can get new cards. And battle rewards, yeah, we can add it as a separate feature, but it's under battle rewards. It's like card rewards, and also like a card rarity system, like one we have in Slay the Spire. Because in order to generate card rewards, we have to know if a card is common, uncommon, rare, something like that, right? What else? We also need to do, yeah, for the shops and battle rewards, we need to do gold. So gold, yeah. Also, we have to generate runs. But by run, I mean a new game or a current game, right? Which consists of separate acts and all that stuff. And if we have runs, so we can switch between battles, the dungeon or the map view, have elite battles, boss battles, all that good stuff. We also need to make sure that we have a save and load system, right? Something to keep track of our progress and all that. What else? We need to have a main menu. I won't really spend like too much time or detail creating a gorgeous menu with like options and all that stuff. You can see that these are really like gameplay focused or gameplay related features. Sure, I could do a video or a 50-minute lesson on options menus, but that's not the point of this course. I want to add these cool interactive systems to make sure that we have a good grasp on the Slay the Spire clone. Because like I feel like options menu is just such an extra feature, which sure you have to spend a lot of time on when you create a fully fledged dream game of yours. But for this tutorial, like I don't see it as a necessity, really. But one thing we also want to make sure is when we add a bunch of new cards and card rewards and all that stuff, we want to have card pile views. And what I mean by card pile views is you can watch your discard, your draw pile, and your deck at any time, right? Just like in Slay the Spire, like the library of cards you have there. So this is a UI thing. And I think that's about it, really. This is more than enough content to fill season 2. But now we have to order them. And so let me switch to a different color. Maybe we can use this red here. Okay. So we'll start with the menu. Why? Because the menu will be the place where we can start a new run. And probably creating a new run is one of the most important features, because we have to hook up our existing battle system and the map generation and the different views we can have there. So having a menu to start a run is really important. But before implementing the run itself, we can do something like this card pile view. And we can do this as like a practice or like sort of a revisit to the old architecture. so we have a complete understanding where we left off. This is more like an easy addition. We could have easily done this in season 1, by the way. It's just something I found that is missing from the game. Yeah, so then we can do starting new runs. And we could do the save and load system. So again, you always have the choice. We can do the save and load system, but I don't think that's a good idea. Why? Well, what do we have to save when we save the game? We have to save a bunch of stuff, right? We have to save the character stats. So we have the current HP, we have the deck, we have the map which is generated. That's need to be saved. The progress on that map also needs to be saved. What else? The relics, definitely. So when you reload the game, you still have your relics. And so if we do a save and load system before all the other things, then we need to revisit it over and over and over again to keep expanding on it. Which is certainly a way to go, but I think we can save some unnecessary work and jumping between different systems if we actually do this last, right? So what do we do next? If we have a way to start battles and start runs, and we have the card pile view, I think we can do the battle rewards and card rewards and rarities. So like these can be all labeled as 4 because they're interconnected. Then we could do map generation. And again, we won't have events like question mark rooms like we have in Slay the Spire, because I think that's a lot of features already. And it's not that difficult to, if you do the full season 1 and season 2 course, it's not that difficult to make the jump and code the event system for yourself. But that's fine. So we just do a basic map generation with battles and stuff. So then we have, what do we do? I think we can do the status effects next. So this can be number 6. Then we can do relics. Then we can add gold and do the shops after that because we have gold to spend. And then we can do the save load system. But now that I think about it, the map will be quite boring if you only have battles. So maybe we can do something like, even if you don't do boss battles, events, and elites, we could still add something that's not on my list yet, but we could do campfires, definitely. And again, I'm not sure if I want to include a card upgrade system, but like, we'll see. I think that's more than enough for season 2, but campfires to heal are kind of essential to play a longer version of the game. And it will give you a good idea of how you could do events similarly, because it's a different view from a battle, which you can enter from the map. So if we do campfires, we can do that when we generate the maps. So we could say that this is like 5-2. And I hopefully won't forget the campfire when I start to record the videos, but yeah, I'll add it to my list too. So this is super useful when you start planning a project, because you kind of have the work laid out in front of you, right? You have a plan, a master plan, how you start to execute creating the game. So next up, we have to think about these features and how these systems will be connected to each other. So we can start with those features. Let me move on to the next page and go back to using black. Okay, so another key thing I want to share with you is like zooming when you plan architectures. And what I mean by zooming is is you have to keep zooming in and out when you plan these features or these architecture things. We have a so-called high-level view, or at least I call it this. These are just terms I'm using. These are not standards by any means. So we get a high-level view. And we also have like we can call this the zoomed out, right? So when we zoom out, we get this view. And we also have the, let's call this system specific view, for example. And this system specific view is zoomed in. So what's the difference between those? So high level systems, or this high level view, this zooming out view, is concerned with systems interacting with each other, and also like game flow, which is the sequences of events, right? So we can call these sequences of events. So let me give you an example. In this high level view, we might want to consider how the Relic system will interact with the battle system, right? Because we have a bunch of relics in Slay the Spire, which, I don't know, deal 3 damage to all enemies at the start of the player's turn. Cool. Now we have to decide how these two very different systems will interact and what kind of consequences these interactions can have. And we need to establish a line of communication between them. We need to sort of examine how this affects the game's flow, the sequences of events, what kind of bugs these can introduce, right? So this is a very high level view where we are not really concerned with how the Relic system works or how the battle implements the turn management, right? We're only concerned with the communication line and the interactions between the two systems. That's what I call this high level view. So this system specific or zoomed in view is concerned with the architecture or the features of one system or one kind of unit in your game. What do I mean by that? So when we zoom in and see a system specific view, that means we want to see how relics get implemented. Do we use nodes or resources for that? What kind of signals we have? Do we want to save them? How do we implement them in the UI, right? All these kind of questions are connected to a system specific or a zoomed in view of that Relic system. And I want to point out the difference between those two because there's a really huge difference, right? And when you plan and create a game, the hard thing about it is you constantly have to zoom in and zoom out and change perspectives, right? Because if you want the code to be prepared for everything you want, we had those pillars, right? The modular, flexible, scalable, easy to add new content. And it's easy to get lost when you constantly switch between those zoom in and zoom out views. But you have to think about both of those. And ideally, you get to answer all the questions you have regarding the architecture. You just need to make sure that you zoom in and zoom out at the right times. So this was just a disclaimer, something I think which is important to think about. And let's see how we can design then specific systems, okay? Because so far I was just talking about like general stuff, but how do we put all these tips and tricks into practice? So if we go back to our previous page, we can see that we have all these features here. And let's see, the main menu doesn't really require a lot of planning. A card pile view doesn't either, but we can do the card pile view as like a warm-up exercise first. Then we can do something more interesting. So we have a feature like card pile views. And how do we begin? I think we can use something. I was thinking about this because before I did this video, I wanted to provide some useful info for you instead of just random ramblings. So I was thinking about how I usually define and design like these specific systems. And I came up with a 4-step process, which I think is pretty cool. And you might find that it's working well for you too. So let's see. Let's see those steps. So step 1. Step 1 is listing the key features. Okay. List key features. Okay. Finally, it seems like I can spell. I will show you all the steps here and then we do them one by one. So step 2 will be after listing the key features. Think about it. Think about the system. Think about the system from a data perspective. Okay. What this means is what kind of data we need to store and use for this. And this means 2 things. Data we need, but also data we produce, right? Which other systems might use. We have to think about those 2 things. Then in the next step, in step 3, we can zoom out and identify communication lines. Communication lines. And what do we mean by that? It basically means answering the question, what other systems we interact with. And also we can come back to our data point here, and that's why these steps are organized into this order. Because after we thought about all the data stuff, we can ask a question in terms of communication that what data we need, or the other way around, who needs our data. Cool. Yes, and also this just basically means that we need to place this system in the existing architecture, right? So we have to find a place for it. And by answering these questions, you kind of do. Okay, I can't spell this word, sorry. Let's just say architecture. Yeah, cool. Okay, and step 4 is also super useful. In step 4, what we do is we kind of think about and list pain points. Or, in other words, possible problems. And this is sometimes called being proactive, like expecting hard things or bad things to happen. And that's super useful. Okay, so this is kind of a psychology related thing, but like our brains are like wired to solve problems, right? And if we take the time to identify and list possible problems, on the one hand, we expect them when we start actually coding the project, which is super cool because we are prepared for the worst. And on the other hand, we sort of kickstart our brain to think about solutions to those problems. Because if our brain is fed with a problem, it can't help but to start to solve it or start to think about solving it, right? So with this 4-step process, I think we can get a good idea or a good grasp on how to implement a feature. So again, to put this in practice, let's start with the card path view, right? Because that's what we started with. And it's a pretty simple one, but it's good as a starting point to use this technique. So step 1 was list the key features of that system. So what our card pile system needs to do? Basically, it needs to display a grid of cards. Display a grid of cards. This means that we need to show like the visuals for the cards. And if you think about it, technically there's no like deck size limit in Slay the Spire. We have game design decisions to like sort of limit it like implicitly, but there's no explicit limit that like your deck can only have 50 cards, or at least not that I know of. And what this means in terms of displaying a deck of cards, or like a card pile, is how we call it in our project. We need to make sure that it's sort of like infinite view. And how do we do this is that it's usually done with a scroll bar, so it's called scrollable. And it's also a pain point, by the way, but it's such an easy system that we don't need to deal with like problematic points because we just have a scroll bar built into most game engines UI systems. And also, what else do we need? We need to indicate the number of cards. Because I think it's just a nice addition, and that's how it works in Slay the Spire. We have these little number indicators on the corner of the icons, which open these card pile views. And I think that's it. Maybe one feature we can add is it pauses the battle when we open it, maybe. But that's I put this with a question mark because I don't know if that's necessary at all. Like, do we want to pause drawing cards when we open a pile? Maybe. We'll see. Okay, that's step 1 done. Now comes the data step, like identifying things from the data perspective. Do we produce any data with this system? Not really. So no data produced. But we need data, right? Data we need is the card pile resource, which contains all the information we need because it has an array of cards, if you remember from our season 1. And that's it, really. So we only need a card pile for this to function. Cool. Step 3 is the line of communication. So this will be a reusable UI scene, right? Because we can use this card pile display for viewing the deck, which is not limited to when the player is in a battle. If you think about it, you can always view your deck when you're in the map, or really when you are in your run, basically. But we also need to make sure that we use the same card pile view for when we want to display the draw pile and the discard pile, and those only exist in a battle, in the context of a battle. So we want it to be reusable. And in what does this mean? Well, I think we can do in terms of communication, we don't need the card pile display itself to handle this communication, right? And what we can do, because we only need a card pile. We don't really care. And now we're zoomed in, okay? So let me stop there for a second so it makes more sense. If we go back to this slide, I said that we have to zoom in and zoom out when we design these systems, right? And we're talking about communication. And you might say that, hey, Adam, communication is a high level stuff. So why do you say that we're zoomed in here? Well, because in this case, think about it. It's a really simple UI scene that does one thing. It gets a card pile from somewhere, and it is capable of displaying all the cards which are in that card pile. So we don't really want to like apply any kind of outside or communication logic to this class, because we can have, okay, so why? We have these in battle and in a run level, right? We can view the deck anytime, and we have the discard and draw piles when we battle. So these two need to be handled differently, right? Because we only want to able to display those card pile views of the discard pile and the draw pile when we play the game, when we are in a battle. The deck, however, can be viewed at any point. So what this means is that this difference needs to be handled somewhere else. Because if you think about it from the card pile views perspective, it's just a window displaying a grid of cards like so, right? So we don't really care about any of those stuff. Like the card pile view is not concerned with how we got there. It's just only concerned having a card pile, and the only thing it can do is it can display it in a grid, and that's perfect. Okay, but somewhere we need to handle the logic connected to it. So when do we show it? When do we close it? But that's something we won't do here. That's the job of the battle scene or the run, not the card pile view itself. I hope that kind of makes sense. I know I'm a bit mumbly here. So what do we need to do? But we need to be, so here, even though we don't really do anything high level here, we need to be able to somehow communicate when we finished viewing the cards. So the battle or the run knows that the player can continue whatever they were doing before viewing this card pile view. So that means that in terms of communication, we need two things. We won't handle like any kind of outside logic. We don't want to make a difference between the discard and the draw piles, but we need to have, so instead we'll have a dependency, right? So we need to have a card pile. We need to somehow initialize a card pile view from the outside, from either the battle or the run. And we can do this with dependency dependency injection. Which is a fancy term, but it just really means that we'll have, in this view, we'll have a property or a member variable for the card pile resource, and we can set this from the outside. And we also need to be able to like notify our battle or run, whichever from those two. We need to be able to notify them that the player's done viewing the cards. Because if that happens, we need to go back to whatever it was we're doing before this. So to do this, we'll also have a signal, which we can call something like card pile view close or something like that. We can also like revisit these names, but for now it works. So we can sort of notify them. So from this feature's perspective, we only need to provide this sort of line of communication, which can be a simple signal. There's no need to use the event bus here because the well, it's up to you. But I think in here it's not really like needed to use the event bus because this UI won't be that far away from the root node anyways. But you can always use the event bus too. It's just you need to make sure. Oops. It's just that you need to make sure that you have some sort of a way to notify it. You can use a simple signal or you can use an event bus signal for this. And in the last step, we need to identify the possible pain points or problems we can have. And here, I don't know, it sounds like such a simple feature to implement. I say this now and I struggle for 2 weeks when I try to actually make the code for it, but that's just how it goes. Now, from a designing or planning perspective, it looks really simple. Maybe the only pain point is like whether we should pause the game or not when it happens, and whether it updates live if we don't pause. And what I mean by updates live is what happens if I, for example, I'm drawing cards while opening the draw pile view. What happens then? So that's like a possible pain point, or it's just a matter of implementation, how we want to handle this. But I think it's not like that important in terms of the big picture. Like that's not the most pivotal point in the game, but it's something neat that's worth considering anyways. So I think with this laid down, we have a sort of a good idea how we can implement this and add it to our existing game. Again, that's not something... Now that I think about it, you can see that I can sometimes work against myself and contradict myself with my own tips. Why? You can see that we'll use this in 2 different places, right? We'll use it for the battle, for discarding and drawing cards. Those 2 piles need to be there so the player can see what's going on with those 2. But we also have the whole deck for the run itself, right? And you can see that I already contradicted myself, because if we go back to our features order, you can see that I said that like doing this card pile view makes sense in the second place because it's such an easy feature to add and we can add it in the beginning. And while that's true, we can certainly do it that way, but then we need to revisit it, right? Because we haven't added runs to the game yet at this point. And so maybe it's worth considering switching up those 2, right? Because that way we already have a run system, So we only need to do this card pile view once because, yeah, let's do this. So you can see that I spend a lot of time thinking about this, and I always found new ways or orders to think about. It's hard to like cover all the ground all the time. So just now by talking to you and creating this video, I already found an improvement. And that's a real good takeaway actually, because if you take a look at the GitHub commit history for season 1, I spent a lot of time thinking about it, and still it was like I was done with the material and code for the 4th video. And during that commit, I also refactored like a couple of systems in the 1st or 2nd videos code base. So you can see that sometimes I also get like new and better ideas later on when the systems or projects or pieces of code are already in their place. And that's fine. You can also go back and refactor if you have a better solution, if it makes the project more compliant to the pillars we have here, right? So that's fine. But you also don't want to refactor forever, because in theory, I think you can always find a new way, a better code, but like eventually you have to create a game. And you can have the best systems and most scalable and flexible code ever. If it never turns into a code, then you are just polishing a pile of nothing, basically. So also need to know when to quit, and that's the hard part. But I digress. Let's go back and I think we can do this 4-step process for a more interesting feature of the game. So what do we have? Let me go back to the features actually. So we have main menu, run, and card pile view. Okay, let's do the run. I don't think it's that complicated either, but let's do the run next. So run. Step 1, key features. Random generated, that's for sure. Random generated map. Okay. We also what do we need for a run? We need a random generated map, but we won't do this until we have maps. So just starting a run means we need to copy a character stats resource, right? That's when we create the copy of it. So we have the starting deck or the starting HP and all those. And this is the car stats resource we use throughout the whole run. If you remember in the ready callback of the battle script, we still have placeholder code saying that we shouldn't duplicate the car stats resource here. We should do this on a run basis, right? Because we want to do this once per run. So that's one thing we need to make sure of. We also, what do we need for a run really? I don't think there's too much else to it for now. But still, let me think. We need to, oh, for sure, we have a lot of stuff, right? We need to be able to switch between different contexts. Or, yeah, we can call those contexts. Different, or we can call these views, for example. So what do we need to switch between? We'll have a map view. We'll have battles. And we also have shops, which is a context. We won't edit here, but that's a feature nevertheless, switching between those. And campfire or campfires. So also, so switching between these means like in more concrete terms, like entering a battle, then exiting a battle and going back to the map, for example. So it goes to map view. So hopefully this gives you the idea that the runner needs to be able to like switch between those contexts. And that's what keeps the game progressing, right? So we can definitely do this without having these systems in their place, right? We can just do placeholder scenes and switch between those contexts to test this. And that's actually the most important part of it. Yeah. Also, yeah, we also have wow, what am I writing? So so we also have battle reward. Like that might be another view we have. Okay, so I think that's the most important, like that's the key feature of this, right? This one. Because the random generated map will be handled by some other system. We don't need the run itself to generate the map. We can do another random generator for this. Okay, step 2. Step 2 is data. So data we produce. Here, I think we can think about whether we want to use. So that's another good question. That's rather Godot specific, but when we design systems, we can think about, especially in data context, we can think about if we want this to be a node-based thing or want this to be a resource or ref counted even. We learned about ref counted together too, so how do we decide between those? Well, resource is a data container which we can serialize in files in our file system, and ref counted is similar, but they are just created and freed via code, and they are not stored in files. So a run, I think, is definitely not just a data container. In fact, there's not a lot of data we want to have. Maybe we can. So what data we need? What kind of data we produce? Actually, I don't think we produce much. One that I can think of is gold and maybe the time elapsed. If you want to be able to like track the time for speed runs or quick runs. But like time elapse is not a feature we listed. So for avoiding expanding the scope forever, we just, let's say we don't track the time for now. And what about gold? Well, we can certainly store the gold in the run itself, but is it a tragedy if we store it in the character stats? With the current health and the deck and all that stuff, I think both of those are fine actually. It doesn't really matter. At least now, I think it doesn't matter that if we store it in the character stats or in the run, because I think either way it works fine. For now, I would say just go expand the character stats resource, add a new property for the gold. It's an integer anyways. It's super easy to handle. And if that's the case, I can't really say anything that's produced by this run script. So if we have virtually, at least for now, no data we produce, then it's definitely not really worth considering ref count in the resource. We can do it in a node-based way. It's much easier because if you think about, there's not a lot of data involved, but there's a lot of logic involved. Switching between these contexts, getting notified when we finish the battle or left the shop or use the campfire, anything like this. So we need to handle a lot of logic, and we need to swap in and out a lot of scenes to switch between those contexts. And for this, having a node is absolutely vital, because if you do it in a node-based way, you have access to the scene tree. Because if you remember, resources are files and they don't have like direct access to the current scene tree. So we definitely go with a node-based solution. Now that I think of it, there will be data we produce, but that's just later on when we revisit this. And essentially, we can't really avoid revisiting this run system, I think, because when we implement saving and loading, we need to store a lot of stuff. So we need to store, so the data we'll produce is like which floor, I think it's called a floor in Slay the Spire, you're climbing floors. So which floor you are in. And also kind of connected to this, the path you took so far. That's usually visible, right? In Slay the Spire, the path you took. Yeah. So that's the data we need to store and produce. But for now, we don't really need that. We'll only need this for when we implement the save and load system. Yeah. So data we need, on the other hand, for now, let's just we'll need to revisit this anyways when we have the map generation, but for now we definitely need the selected character. We want to play with, and I think that's it. We might also want to do a seed system so we can have fixed seeds. Not sure. I think that's kind of outside the scope again for this tutorial, but if we had a seed, that's also data we need from the menu when we enter a new run. Communication wise, okay, so let's move on to the next page. And we're still dealing with runs. And communication wise, this is another useful technique if you want to sort of get a picture in your head how this looks like, is to create like a hierarchy. Maybe even draw it out here. So we'll have like some sort of a game on the top, or a main level. And under the game, we'll have the menus and all, but we can exclude the menus. And then we actually have the run. And under the run, for example, if you take a snapshot of the game where we play a battle, we can have like a current battle. And under the battle, we have all the stuff we had from season 1, right? So we have like enemy, handler, we have the battle UI, we have the player, and so on. So we have all those systems under the current battle, right? So when we think about establishing communication, it helps to have a hierarchy in your head, so you know who you need to communicate with. Because if you think about it, the battle can handle itself, but the battle needs data from the run to operate, right? So So the run is sort of like a central place, more like a distribution center in terms of communication. You need to provide the dependencies for all the systems who need them. So what does this mean in terms of communication? Well, the run will communicate with the battle, that's for sure. And for the battle, we provide character stats, the current stats of the player we have, and also not just the character stats, but like enemy info as well. Because we'll need to have some sort of information. When we have multiple battles, we'll need to have some sort of a system to make sure we can generate encounters or like enemy stats or enemy data or something like that, which we don't have currently. But we have to provide that to the battles. And it's the responsibility of the run, really. So in terms of communication, we have to communicate with this. We also have to communicate with the map, which we don't currently have a plan for, but like I'm just thinking, and a good question here is whether the map will have the info for the encounters or not. Because if so, then the run itself is basically a mediator. So when you pick a point in the map, pick a battle, then the map will have this enemy info on itself, and the run gets this from the map and passes it on to the battle. So we can start the corresponding battle here. So with picking battles, and also picking battles, and also like progress, or we can say showing progress on the map. So showing progress. Yeah, and also, so in this case, the run scene or the run system needs to communicate with the battle and the map, and also receive some information from them, because the other way around, the other direction of the communication will be the battle communicating with the run. For example, signaling when the battle is ended. And I was thinking about like registering the rewards, but for this, the battle doesn't need to communicate with the run, because we can, if the gold and the deck will sit in the character stats resource, there's no need to communicate, but the run needs to be notified when it's ended, so we can switch the context, and also we can show the progress on the map. And also we have this communication to the other direction from the map to when we pick a destination, because that means again switching the context and sending the appropriate data as well. So we can pick campfires, we can pick battles, and the run needs to be notified, so we can react accordingly. Yeah, and I think that's all the communication we need from the run, at least for now. But let me take a quick look at the features again. Yeah, for sure the same goes for like campfire and shops, but I think you get the point. So like, why we don't need to write them too, but it's the same. Like, we need to be able to have this bi-directional communication between them. The shop needs to be notified with the character data, or needs to provide the run needs to provide the character stats resource to the shop rather, and the shop will notify the run when we left the shop. And the same for the campfire, so it's not that complicated. It's the same thing we have for the battle and the map here. And the final step is to identify the possible pain points or problems we have for the run. For now, I can't really think of problems if we don't want to deal with seeds and all that stuff. Not so far. Maybe the saving and loading, but that's a future problem, right? We have a different system for that, but like, yeah, we can state it. Like, keep in mind that we need a save load system later, but we need to. So what's hard about this? Deciding what to save, and also collecting the data, because what I'm thinking about is collecting the data. So what I'm thinking about is that probably the data we collect will be in a lot of different places. We need to have the data from the map. We also need to save like the items we can encounter in the shops. The character stats need to be saved, the current path we have. So we'll have data like lying around in different places, and we need to somehow orchestrate collecting all the data we need to do this save load system, but we need to revisit this when we plan the save load system out. So again, just to sort of summarize what we have for the run will need to copy the character stats resource so we can start a new run. And in terms of features, the most important feature is to provide an interface to switch between different views in the game, namely the map view, the battles, the shops, the campfires, and the battle reward screen. And we went with a node-based solution. And in terms of data we produce, we only talked about progress and which floor you're in for now, but that's only needed when we'll implement the save load system. And in terms of data we need the selected character from the main menu. So we can say that, okay, we started a new run with the warrior. And that's all we need. It's basically the save the character stats resource, which we want to duplicate when we start a new run. And the run itself is like an upper level system in the hierarchy. So it's more like an orchestrator and a dependency injector for the other screens we were talking about. And just to give you an example, I sort of drew this hierarchy and talked about the battle and the map. But we also need to consider all these screens we have here. But we can only implement them when we already have those systems in place. So we can only hook them up with this run screen. But we don't just have the battle and the map view, we also have shops, campfires, and the battle reward screen too. But it's usually like a bi-directional communication, because from the run downwards, we need to pass the dependencies, which is usually the character stats resource. And the other way around, we need to be able to signal the run system, this orchestrator, from all the screens when we exited one. So when the battle is finished, then the run needs to know, so it can display the battle reward screen. When we pick the destination from the map, the run needs to be notified, so it can switch to the provided context we need for that new destination, be that a battle or a campfire or a shop or whatever. And the same goes really for the shops, the campfires, the battle reward screen, but I just didn't want to write the same thing over and over again here. And the possible pain point, which we'll only worry about in the future, is the save load system, namely collecting all the data from the different places we have. Cool. So now we have an idea how we can do this. And another important note here, you might say that this architecture overview is not specific enough for your taste. And what I want to say here is that there's no need to get lost in implementation stuff in this stage, I think, because we don't really care about how, if we go back to this like card pile view thing, we don't really care about like, should we use a scroll box container or a grid container for this, right? These are very implementation specific or UI specific and even Godot specific questions. And we don't really need to care about those at this point. As long as the architecture remains the same, what matters now is that we hook this up with this card pile resource and we want to have the dependency injected. That's all that matters. We don't really care how the UI itself will look or how it's implemented. We can change that later on if we want to. And just jotting down the simple words, ideas, and like bullet points is perfectly fine at this stage. You always have to, like, nothing is set in stone, right? You might refactor, you might have better ideas. It's perfectly fine. At this stage, you just want to have like an idea in your head about how these systems can interact with each other and how they can communicate. And it's not a final, or that's not how my code will look by any means. It might be completely different, but that's just like a general initial idea in my head. We don't really want to get lost in implementation details. You don't have to think in terms of code at this stage, I think, at least. Okay, so with this out of the way, I think we can do one more feature. And I know it makes sense to like keep the order the same because we skipped the menu, we talked about the card pile view, we talked about the run. We could do card rewards and card rarity next. But why don't we do something really interesting here, right? So we can kind of change up things a little bit here. And one of the reasons I want to change this up is because I think you can learn a lot from a more complicated or more problematic system. So let's do relics. I think that's the biggest pain point of this game. So relics. Step one. Step one is key features. Okay, so relics persist throughout the whole run. They are visible at any time, so we can say always visible. That's probably easier. Yeah, always visible. They are very, very different. And we could say diverse is a good word. Yeah. And that's a huge reason why state spread is so great. And also a very, very big problem and pain point with this architecture planning. So we can't really say what they do, but like we can say that they affect gameplay in a way. In a way. And also here, maybe it's interesting to think about when these relics do their thing. And I could pull up a list of relics in Slay the Spire, but there's a really long list, and I don't think it's that much better if we go through like a list of 1,000 relics. What we need to care about is when they. So it's a key question. It's not a feature, but it's really important to know at this stage that the key question is with relics is when do they, how do we say this? When do they get activated? And that's super, super, super important, right? Think about some relics in Slay the Spire. When do they get activated? We have so many relics, right? Just some examples. During battles, right? Start of turn, end of turn, start of combat, question mark rooms. What else? Shops. You have the discount card, right? Everything is cheaper. You have every fourth question mark room is a treasure room. You have at the start of combat, I don't know, the first attack you play is played twice. End of turn, you gain 6 block if you have no block or recalcum. Start of turn, damage all enemies. Mercury Hourglass, right? So those are really, really, really different use cases. And we need to be prepared for all of them, actually. We also have like one-time relics, like the old coin, which gives you like 300 gold, I think, or 400. So these are super, super different, right? So somehow, and I think this is probably the biggest pain point of this whole project and season, is that we need to create a system which is somehow flexible and modular enough so we can make this work. And that's the hard part. These are the key points of relics, I think. Maybe we can say that also no limit. So you can have any relics, any number of relics you can get your hands on. Yeah. So let's go to the data point and see what we can come up with for the relics. We have, if you remember, we have the two things, data we produce and data we need. Data we produce is probably the easier part. Relics will have a name, an icon, and the tooltip. And with this, we can definitely store this in the resource, right? So we can create all the relic. Because these are data we don't really want to modify, or I mean modify from code. We just need to access it so we can display the relics in a relic bar, like in Slay the Spire. You can call this like relic data or something. So this can definitely be a resource. There's not much else we produce, right? This is just well, we can also have an ID, which can be useful when we compare things. So if we have a relic or not. So it's always useful to have a unique ID for each relic, or might be useful. We might end up not using it, but like it doesn't hurt to have like a string ID. We have the same for the cards. Data we need, well, this is a big question mark for me, because that completely depends on the type of relic, right? And we don't know. We don't know. We can't say that, like, generally speaking. We can't say that all relics need this data. Do we have something which is shared among all relics? I don't think so. We definitely need a relic data resource, but like that's just to identify ourselves. We can say that it depends on the type of the relic. So we can't say that for sure. And here, I think it makes sense to move to communication, because that will enlighten us. How do we do this? So we have a super interesting question first, which we need to answer before moving any further, I think. We can handle these weird varying dependencies two ways. So the question we need to answer here is, do relics handle logic on their own, or do the systems handle them based on their type? What do I mean by that? Let's draw an example here. So we have excuse my drawing, we have the Mercury hourglass here. Okay. So what this does is 3 damage per turn. So when do we do this 3 damage? Well, when we are in a battle. And what the second question implies is that the battle will iterate through all the relics the player currently has. And if it's a relic which does its thing during the start of the turn, then we call something like an execute function and let the relic do its thing. This way, the battle system is responsible for firing all the battle-related relics, right? On the other hand, when we decide to do the other one, what we do is we notify the relic that there's a battle and a battle turn has started, right? So battle turn started. And let the relic do its thing without the battle worrying about the relics at all. And both of those solutions, or both of those approaches, are okay, I think. If we zoom out and take a step back to the very beginning of this video. I think that's a bit tightly coupled though. I mean the second one. So if the battle starts worrying about handling relics, then the battle is dependent on having a relic system in our project. It might be easier to do it that way, but also we sacrifice some of the flexibility and also maybe sacrifice some of the modularity as well. Because the battle script and all the other systems which do their thing become a bit longer because they also need to like deal with relics, right? So I think it's kind of intuitively we would kind of say to go with the first one, right? The relics should be like encapsulating their own logic and they can execute it when they want to, right? And I agree. I think that's the better solution. However, that leads us to a new problem. Why? We need to think about the flow or sequence of events in this case. So what happens when let's just go with the on the start of the turn, right? Start of the turn relics. Okay. I think that's one of the most problematic points in this project. So start turn. What happens when we start a new turn? Well, we start drawing a new hand, right? Drawing a new hand. Then we play cards and end our turn. That's the sequence of events right now in season 1. So the problem is, where do we like insert handling the relics or the relics handling themselves? I think it makes sense that like at least how it works in Slay the Spire is right after the new turn begins, the relics we have will like sort of execute their effects, and then we can only then start drawing a new hand and play the cards. Or maybe I don't know from the top of my head. Maybe it's here, like after drawing a new hand, but before you can play cards, the relics execute their effects. But I'm pretty sure that you can't play cards while the relics are doing their thing. Yeah, and that's fine and all. But if you think about it, we have an event bus, right? And so the problem with the event bus, it's a really cool pattern. But the problem with the event bus is we have our little events, right? That's a singleton that exists everywhere in the game. And I'm also, by the way, I kind of morphed into step 4 talking about communication and pain points at the same time. So we have our events. We have the let's say we have the battle connected to this. It's probably not just the battle, but the player handler. But to make it easier, connect the battle to this, and we can connect our relics to this. And so what happens is we emit a signal from the event bus. Call this, I don't turn started. And what happens is that the event bus will notify both the battle and the player handler and the relics, if we have a relic system in place. The problem is there's no guarantee of orders here, or if there is a guaranteed order, it's not like trivial, right? It depends on the node order in the scene tree, which is probably not the best because, and that's one big disadvantage of the event bus is that you don't have a clear flow or sequence of events you can rely on. See my point here? There's no guarantee that or at least, as I said, it's not trivial that the relics will always be notified before the battle is. And even if it's the case, if we connect two functions to these signals, so let's say we connect the relic's execute function to the turn started signal, and we connect the battle's draw a new hand function to the turn started signal. There will be a fixed sequence of events, but even so, there will be so little delay between the two function calls that practically they will run the functions simultaneously. And that's a problem, right? Because I start executing the relics, and at the same time, I start drawing my hands. And you might say that it's not a problem with doing 3 damage per turn. And that's true, but I hope you see the problem with this. Down the line, when you want to add new, cool, and interesting relics to the game, this might cause a whole lot of trouble to us. So many unexpected bugs, unexpected behavior might arise from this that it's mind-boggling, really. Let's say you have a relic which draws a card and then you have to discard one. And if that gets called at the same time when we are already drawing a new hand, you can see, I hope you can see that it's super problematic. So somehow we need to make sure that we create a flow or sequence of events which makes sense, right? And we need to make sure that even if they get notified almost at the same time, but never at the same time actually, but almost at the same time, we can still somehow maintain a consistent flow of events. And that's the problem with this. That's the pain point of this encapsulation plus event bus method we're going for here. I still think it's worth going with this version over the other one, polluting all the other systems with a tightly coupled dependency, but it requires a lot more thinking, and I've been thinking about this actually. If you have any other ideas or better ideas than what I propose here, please let me know in the comments because I'm super interested in your ideas too. So what I came up with here is, and it's actually, I think it's, just to backtrack a little bit, I think that's only a problem with battle-related relics, right? Because if you think about the other ones I mentioned in the previous slide, like question mark rooms and shop and one time and all that stuff, these are not that hard to handle. Like here, we can always just say that these need to be the first to do. So before entering the shop, we can fire an event from the event bus and the relic can do its thing, right? So it's not that big of a deal at other places, but in combat or in battle, when a lot of things can happen simultaneously, then that's a super big problem. So the solution I came up with, or the idea at least at this stage, is to modify the battle scene a little bit. And what we want to do with the battle is I want to have a new, let's say, add a new node, or let's call it a node and a script. And I call this something like task queue. And if you don't know queues, it's a computer science idea or data structure. And the queue works like this. It's basically kind of like an array with some constraints. So we have, maybe brackets is not the best way to show this. So let's say we have something like this for a queue. Okay. This is a queue here. And how a queue works like, we can like sort of assign different slots to a queue similarly to an array. And what a queue does is when we have two ends, right? And what we do with the queue is we insert elements from one end. So let's say we, I don't know, have a, like I call card draw. We insert this first. And then we insert a new one. So this moves up one space. And we insert a new one for a relic, which can be Mercury Hourglass. This is no longer here. Let me erase it. So we add these effects to the queue. And we have the card draw task, and we have the Mercury Hourglass task. And what we can do is we can populate this queue with all the tasks we need to perform at the start of the turn. And at the end of the frame, when we are sure that all of those tasks are added to the queue, at the end of the frame, we can do a while loop. And how a queue works is we put tasks or values in one end, but we get values out from the other end. And so what we do is at the end of the turn, we can empty this queue by looping over all the tasks we have and perform them one by one. And so this gives us a better control over them, right? Because we have basically an array, but it's a queue because we use the two ends to put in and get out things. Even though the tasks, when they edit, it still gets done kind of simultaneously almost. But so let me gather my thoughts here. So even though we still kind of simultaneously add them to the queue, right? But they don't start to execute what they want to do right away. We just put in like a sort of like a post-it note to this queue that, hey, we want to draw cards. Hey, we want to execute the Mercury Hourglass effect. And what we do is instead of kind of simultaneously almost executing them right away, we just store the requests in this queue. And at the end of the frame, we remove those requests one by one and execute them one after the other. So what we do is we draw the cards because that's on the top of the queue. And then we use the Mercury Hourglass. And this way, by looping over them and removing them from the queue one by one, we have control over the sequentiality. Is that a word? We have control over the flow of the events rather. So we can make sure that it's a sequence and they don't get like stacked on top of each other and execute simultaneously or asynchronously. I hope that makes sense. So for now, I think that by implementing a queue in the battle scene, we can avoid this problem of flow of events we have here. Because in a turn-based game like this, you really, really don't want to have asynchronous events. You want to have like a clear sequential flow of events. And I think we can achieve this by adding this queue. But again, if you have other ideas, or let me know in the comments what you think of this idea. I think this might work in theory. I didn't write a single line of code yet, so there's really no tell, but I think it might work. And yeah, so you need to loop over the queue in summary. And when you emptied the queue, that's where you know the player can start playing cards. So while the loop is not empty, you still prevent the player from starting playing cards and causing more unexpected behavior. So let's summarize what we have for our relics. So we said that relics throughout the run, they persist, and there's no limit of how many relics you can have. And also they are always visible, so you can read the descriptions or what they do. And they are very, very different and diverse and affect the gameplay in a lot of different ways. So the key question is, when do they get activated? Because we have to be as flexible as possible with relics. So there are start of turn relics, end of turn relics, start of combat relics, question mark room relics, shop relics, all that stuff. And this comes down to deciding the communication and the implementation of relics. In terms of data, we can't really say much because the data we produce is easy. It's just like a data container for the UI of the relics, the name, the icon, the tooltip. But the data we need is super dependent on the type of relic. And we ask these big questions like, do the relics handle the logic on their own? Or do the systems handle them and sort of filter through them? And to avoid coupling, we decided to go with the first one, which presented a new problem of unpredictable simultaneous execution of events. Because the event bus will emit this turn started signal, and both the battle wants to do its thing by drawing a new hand, and the relics want to do their thing as well. And even though there will be an order between the two, but the function calls are almost asynchronous, so there's really little time between them, which means we end up in a situation where we have no flow of or sequence of events. Things happen practically simultaneously, and we really don't want that in turn-based game. So in order to avoid this, my idea is to implement a new task queue in the battle scene, which is a big refactor, by the way. And that's a game dev reality for you, because I didn't plan doing season 2. I never thought about using a queue because I saw no need for it. But now it's clear that we need to apply some modifications. Anyway, what we want to do with this task queue is to not execute all the actions right away at the start of the turn, for example, but rather just use some post-it notes, add them to the queue, oh, hey, we should draw cards later on. Oh, hey, we should execute this Mercury Hourglass Relic later on. And when the queue is populated at the end of the frame, when we are sure that the queue is populated, we can loop through it, remove the events or the post-it notes, and execute those actions here. And what's cool about this is we sort of regained more predictable and more structured flow of events, because when looping through, we can wait for the previous action to finish before moving on to the next one. And one thing that's also worth mentioning after summarizing, I think, is that the relics, in order to be able to have this encapsulation we want them to have, we might want to refactor some events, which means we have to change some signals in the event bus, probably, because in order to make sure that the relics can do whatever they want, right? They want to handle the logic on their own. For that, they need to subscribe to events or connect to events from the events bus, like these turn started. But if you think about it, in order to this Mercury Hourglass to do its thing, they don't just need to know that the turn has started, they might also need to have access to all of the enemies or the players. Even though you could get those entities from the groups we have, that's not always the case for like shop relics, for example, right? Because you need to either have access to all the items or the items you can purchase from the shop, or add the modifier to the shop so all the items get discounted or something like that. So keep in mind that when we do these relics, we need to design events in a way that relics can have the dependency injected to them through that event, if that makes sense. But that's something we only need to worry about when we actually implement relics and events in the game. So yeah, I think we came a long way, and that's more than enough architecture talk for the video. I hope you learned something, and let me know in the comments if you want another one to sort of plan ahead the whole game before actually starting the tutorial itself. And that's it for now. Have a good one. Bye bye.